Hello and welcome to another pcalc stream. Been a little while since I've done one of these. We had the Christmas and New Year's and such, so we had a bit of a holiday break, but we are back now. And so what we were doing last time, if I remember correctly, is we were gonna try out the XCB build again. And because we got a failure in the X11 build, it fails to connect to the X11 server. And so we want to know what does the XCB build do, because it connects to the X server just fine. So yeah, we see fatal, no protocol specified is the error we get. Not exactly what we want to see. So let's see here. If we go to build.d, and at some point I want to switch this back to using the CC1 mode of compiling and get that all going good. But for now, I just want to focus on getting this much working, and then we'll go back to playing with the build script. But so let me see here. So we should be able to specify the XCB backend. I just want a refresher. I guess I could have just done r./build. Show me help. Yeah, so the backend can be used. So we're gonna say build.d-b xcb. We get a seg fault though, so we broke something since we last used the XCB build. And then one thing I want to point out that I haven't forgotten, we're going to get to it. Everywhere we use the syscall, now that we know it returns negative error, I need to change my error handling for everywhere I call a syscall to treat it as the error number. But so let's run pcalc through GDB. So what happens? PLT init NWR region create failed. I feel like this was something we fixed. I think what happened is we fixed this in the X11 build and didn't fix it in the XCB build. So if we look at our PLT init, this is what it should look like. And this is what this one looks like. Looks the same to me. So I was wrong. The code is updated, but it doesn't work on the XCB backend. Why not? In Fatal, NWR region create build. Cannot access memory. Add address, and this would be a -1 in a signed representation, 2's complement. The thing that I notice all the time working on this program is it would sure be nice to have pcalc, the program, so I could see things like that. I'm starting to develop the intuition of like, oh, that's a signed -1 is what you're looking at right there. In a previous pcalc episode, we were looking at the result of mmap giving a negative number, and I thought it was just a really high address at first, until we learned that it was probably actually a negative number, and we looked and we figured out what it actually was. But you know, if we had something like pcalc, we would just see that right away. But you know, this is the pcalc programming streams. We're making pcalc, so we can't rely on it because we do not have it yet. We are building it. So, but I am developing that intuition just from working on this program, I think, and being in the debugger more often than I usually am. But yeah, we cannot access memory at -1 in the SDB as printf call. So that happens in Fatal. Okay, we allocated it using sbreak. We put it on this, on not the stack, on the heap using sbreak. The problem might be that our heap is managed. We're using things like malloc, and you're not supposed to use sbreak in combination with those because malloc is like built on top of that and providing a general purpose allocator, whereas sbreak is just providing like a basic bump the pointer allocator, a region allocator. So we might want to rethink how we do that. Yeah, sbreak is returning -1. We're not using our own implementation of sbreak, of course, because we're using the XCB backend. So it is, sbreak is a wrapper returning -1. We could check why it's returning -1, but you know, fundamentally we shouldn't be using sbreak in this backend. So these three calls to sbreak need to change. We cannot use sbreak in our common platform layer. That is a fundamental mistake we're making. We need to abstract the way heap allocation is done if we're going to keep it on the heap. Which I think I do want to keep those allocations on the heap. So I think what we're going to need to do is create an abstract allocator to do these things. Of course, we have an abstract allocator, plt-alloc, but that's not what I'm talking about. I'm gonna make like a plt heap, plt heap alloc, or like plt malloc. You know, something like that. So yeah, we're gonna create a plt malloc, and it's gonna be a just a wrapper for malloc on the xcb backend, but on the X11 backend, it's gonna be a wrapper for sbreak. And then free is going to be sbreak as well on the X11 backend. So we're going to want to take the size yeah, and then for free, we need free to take the size. Because it needs it on the X11 backend. Whereas the this backend needs the pointer. Or I guess just free pointer. You know, the thing is, this backend only needs the size. Whereas the other backend only needs the pointer. We could just use one parameter and cast it. You know, like this could take a pointer, but then you just cast it to a size t and pass it, you know? You know what I mean? Why don't we do that? We're just gonna reuse the parameter. Here, I'll call it pointer. Well, no, actually, we don't want to do that. The reason we don't want to do that is because it changes the way we call it. It changes the call site. So we do want this signature. That should be called PLT free. Same thing here. Let's move it down here. The other thing is I'm going to need to error handle in this. But let's go back to the call site first of all. So this is where we're going to be using it. This becomes a call to plt-malloc. This becomes a call to plt-free. Like that. This one we malloc but not free because it crashes the program. And there you go. So now the error handling is the next thing. So I was saying if it's less than or equal to 0, return. So we're going to use that same kind of signature. Let me see, what does malloc do? Return value. Returns null on error. Now my sbreak implementation that would be in Linux. Okay, so my sbreak returns -1. So I do implement that. Now let me see my break implementation though. So when this has an error, this would actually be returning an error code. But I think this is still correct. That new break would be less than address if it failed. So I think my implementation on this is fine. I think. I could be wrong, but I think it's fine. So checking if it's less than or equal to 0 should be fine, because if it's equal to 0, it's null. And if it's less than, it would be -1 like sbreak returns. So this would handle both potential implementations. So the interface of my platform malloc is that it returns a value less than or equal to 0 on failure. I don't see any reason to overcomplicate that, so I'm happy with that. And let's see if we can get it to build. A couple errors. We probably need to do an include somewhere. Implicit declaration, okay. Oh, because I'm using them in platform common. So we have a plt malloc that takes a size t. We have a plt free, which takes a void pointer and a size t. Okay, 2 warnings generated, but it built and linked. And the errors are just about those comparisons, so we might as well fix that. Cast that to a size t. Where was the other one? There it is. NWR region create build, okay. Why would NWR region create fail? Is my mmap failing? Oh yeah, I forgot to map private here. There we go. So now we've got something we can debug. Looks like it's working fine. Looking good. Okay. So that is connecting to the X server correctly. Question is, what is it doing to connect? So where do I want to break it? I want to break it in plt create window. So we're going to do gdb pcalc break create window. Oh, what's the command? Okay. There's got to be a shorthand for that. I think it's just like B or something. Okay, so run. Step, step. Okay, here we're doing the XCB connect. So if I step, does it step into XCB connect? I want it to. Looks like it did. So it's calling XCB connect to display with auth info. That's what I expected it to do. Okay, now we're inside connect to display with auth info. Okay, so it's going to parse the display now. So getting the display number from this, and that should give us 0. So let's see what happens here. Okay, so it gets the environment variable display. We do that as well. Okay, so determine that the protocol is empty. Finds the colon. Grabs the number from it. Calculates the length. Does a malloc. Mem copies. That's display P. That's screen P. Okay, so it returns 0 because we're taking the if not parsed. We're doing XCB open next. Again, this is like what I expected. So Host optimized out. Protocol optimized out. Why are these? That's annoying. This should be a debug build. I don't know why stuff is getting optimized out. But let's keep stepping, I guess. Okay, well here we can see the values. Host equals some number that looks like garbage. Protocol is equal to 0. Display is equal to 0. So if not protocol will get taken. Okay, so now we're back in XCB Connect display with auth info, it looks like. So we got a file descriptor. We say file equals malloc file length, apparently. File length is 30. Okay, this is doing an SN printf file length with base and display. Which sets it to 17. It takes the min, so that's going to be 17. Okay, interesting. It's doing XCB Open Abstract. I expected it to do XCB Open Unix. So that's different than I expected. Oh, it's telling me file length got set to 30? Thought it would be 17. It said min of actual file length and file length -1. Actual file length was 17. Not sure why file length is 30 here, but okay. But we're getting a file descriptor using an open abstract. Let's keep looking here. Okay, well, here we've got the sockadder Unix sock address. It did a string copy for the path, so it was setting the file name. So that's the path to the socket, and then that's the AF Unix. So that should be like the same thing I'm doing. I can't print the sun path though. It would be nice if I could. I guess it must be a release build of the library rather than a debug build of the library. It's statically linked, but I suppose we didn't compile it in debug or something. Like the actual program is compiled in debug, but you know, when it linked in the library object file stuff, the static library, that code must not have been debug. We call xdb socket. So we're setting family equals 1, type equals 1, hardwidth CLO exec, proto equals 0. So I set family to AF Unix, type to sock stream, proto to 0. So I wonder if I need the type to have the CLO exec like set. Let's investigate this a little bit. Sock stream is defined to be 1. So yeah, they're Ring it with CLO exec. I'm not doing that. So that could be the problem. That's one difference. What is sock CLO exec for? Man sockets. Or sorry, man 2 socket. CLO exec sets the close on exec flag on the new file descriptor. See the description of O CLO exec flag in open for reasons why this may be useful. So I'm feeling like this is probably not what we're looking for, but let's read the description of it in open. Permits a program to avoid additional fcntl fset fd operations to set the fd CLO exec flag. The use of this flag is essential in some multi-threaded programs. Doing it the other way, using the fcntl, does not suffice to avoid race conditions, where one thread opens a file descriptor and attempts to set its close on exec flag at the same time as another thread does a fork plus exec. Depending on the order of execution, the race may lead to the file descriptor returned by open being unintentionally linked to the program executed by the child process created by fork. This kind of race is in principle possible for any system call that creates a file descriptor whose close on exec flag should be set, and various other Linux system calls provide an equivalent deal with this problem. See, now we're not multi-threaded, we're not spawning child processes. Like this stuff shouldn't matter to us, and it shouldn't be the reason for our problem. Let's keep stepping. Okay, so now we're back in XCB Open Abstract. Or I guess we were in XCB Open Abstract already. Name length equals offset of. Whereas that's optimized out. That doesn't really help us, but we do the connect call. See, now I'm just doing size of server address, whereas they're doing name length, which is offset of the struct, the path, +1 plus file name. Man to connect. So that's supposed to be the address length. So that could be the source of our problems. The size, the address length. Let's keep stepping, but that catches my attention. Let's remember this. That was line 477 in xcbutil.c. Here we go, it's this line right here. So I just want to keep that in the back of my mind, but I want to see what else it's doing. So we're back in XCB Open. So we free the file. Okay, here we're doing the XCB get auth info. This will be interesting to see if it's going to make us do authentication. So it's busy reading the auth information right now. Which I don't do because I assume we don't need to do authentication, but what's going to be interesting to see here is if it decides it does need to do authentication. So we're still in XCB get auth info, but now we're doing compute auth. Freeing a bunch of stuff. Okay, so it's doing XCB connective file descriptor with XCB connected display with auth info. Okay, well here we see information. So there's some data. There's a MIT Magic Cookie 1 in the name. Data length is 16. Name length is 18. So it looks like we are doing authorization after all. MIT, what was it called? Magic Cookie 1. I want to see what searching that turns up. Okay, X window authorization. Okay, there are 5 standard access control mechanisms that control whether a client application can connect to an X display server. They can be grouped in 3 categories: access based on host, access based on cookie, access based on user. Bundling can be used. So we're using cookie-based access. So there are two systems using this method, MIT Magic Cookie 1 and XDM Authorization 1. So in the first method, the client simply sends the cookie when requested to authenticate. In the second method, a secret key is also stored in the .xauthority file. Client creates a string by concatenating the current time, the transport dependent identifier, and the cookie, encrypts the resulting string, and sends it to the server. Okay. So it's looking like we're going to need to do that. We're going to need to do MIT Magic Cookie 1 authorization is what it seems to be what we need to do right now. So there's also user-based access. So yeah, I think we're going to want to go with the MIT Magic Cookie method. That's what XAB does. That seems like the way to go. So yeah, I'm going to keep stepping for a bit, but I'd say we figured out what we need to do at this point. We need to do MIT Magic Cookie 1 authorization. So here it's doing the stuff we do. Oh, and we're back in PLT create window at this point. Okay, so I think I'm going to end the stream here today. We'll continue it tomorrow. I mean, not in the stream, and pcalc. We'll do some book club. Before I do that, though, one thing I want to check is what is the value we're getting back from Connect? So it returns an int32t, and I'm just going to do a debug build the X11 version. Okay, connect returns 0, so that's a success then. It would be a negative number if it was an error code, because it would be the negative error no. So yeah, I'm going to continue to not handle errors on the connect right now. I should probably put error handling in there at some point, but that pretty much confirms what I was thinking, that it's not the connection that failed. It's not the writing or reading. I mean, we knew that because we were getting a reply. So yeah, it's because we actually need to do authentication. Anyway, I will see you guys in the next episode where we start implementing authentication.